All right, let's get started. So my name is Dan Rosenstein. I'm a lead principal program manager on the IoT team for the Windows and Devices group. If you're here to listen about Windows 10 IoT Core from maker to market, you're in the right place. If you're not, you should stand up and leave the room right now. So today we will be going through a series of demos. We'll have some live demos. We'll have some videos. We'll have some click-throughs. Should make for a pretty fun talk. What I'm going to be talking about is Windows 10 IoT Core from maker to market, as the title of the deck says. Every time I've practiced this deck, every time I've practiced this session, sometimes I run long, sometimes I run short. So if I run long, I'm sorry to the analytics with R and SQL guys following me. If I run short, I work with a fantastic team of people who are sitting up front. We're going to be available for Q&A. And if I end on time, free waters for everybody in the room. All right, so where I want to start is in the landscape of IoT, and I only have one landscape slide of IoT. I'm not going to stand up here and tell you that people are projecting there's going to be 16 billion different devices. Instead, what I'm going to tell you is that IoT devices have all kinds of different device capabilities. They go all the way from entry to the most complex with their device capabilities, and they go from a low price point to a high price point. One of the things that IoT devices share is that they interact with the physical world, and they take feedback from that physical world, and they put information into that physical world. They react and manipulate the physical world. Some of these devices have displays on them. Some of them use keyboards and mice. Some use natural user interfaces. Some of them operate on a factory floor and just operate by themselves without a display or a care for the world. The common thing between all these devices is we need an operating system that can power all of these. And that's why we designed and optimized Windows 10 IoT Core. Windows 10 IoT Core is the next generation of powering the next generation of intelligent devices. And with Windows 10 IoT Core, what we've done is we've created three pillars around the product. The first is one Windows platform. The second is that we have a connected platform. And the third is the promise of a secure Windows platform. And at the center of that is Windows 10 IoT Core. If you want to hear more about connected, Jason Farmer gave a great session on Wednesday called Windows in the Smart Home. You should go check that out. And if you want to hear more about secure, check out Brett Benson's IoT Vision and Strategy session that he did on Thursday. For the purpose of this discussion, this session will only be on the one Windows platform. This is a level 300 dev-centric session, and I'm hoping you guys are going to have fun. With Windows 10 IoT Core, it was designed and optimized specifically for small, low-cost devices. With Windows 10 IoT Core, we offer silicon choices. You can target devices with lower system requirements. What that means is we are the only edition of Windows 10 that is enabled on both x86, x64, and ARM platforms. All the other editions are either x86, x64, or ARM. Windows 10 IoT Core is the only one where you have choice across ARM and Intel chipsets. The next thing is that we target devices with lower system requirements. We have a certain level of customization where you can disable things like the graphics stack if you're not using it to target lower system requirements in your solutions. What this enables is opportunities for targeting new device types, like those shown on that first IoT slide, where some of those devices have displays, some of them don't, some of them use keyboards, mice, some of them don't. And we also, since it's part of the Windows 10 platform, and just one of the Windows 10 editions, we offer app and device telemetry, and we'll be talking about that more. When we talk about silicon choices, we have 3 developer boards across 4 different corporations. The first one is the Raspberry Pi 2 and 3, which uses a Broadcom chipset. There's the Intel Minoboard Max, which uses the Intel Bay Trail, and the Qualcomm Dragon Board 410C, which uses the Qualcomm chipset. And each of these is supported with Windows 10 IoT Core, enabling you both ARM as well as Intel chipsets and multiple different ARM chipsets as well. The way we think about Windows 10 IoT Core and the developer journey for IoT development is our fundamental premise is that any developer can build an IoT device. Now, this slide is the money slide as far as my session is concerned. If you fall asleep after I'm done with this slide. The way we look at it is developers come in multiple different classes, come in multiple different groups. You have learned across the complexity continuum. You have learners all the way on the left, tinkerers, enthusiasts, maker pros, enterprise innovators, startups, and OEMs. Developers are represented across this giant ecosystem. Learners are the ones who are just getting started programming. Tinkerers are those that have done a little hardware, done a little software, but they're not professional developers. Enthusiasts are the ones who take the newest, latest technology, get working on it, create great things. They create a fantastic community. Maker pros are the enthusiasts who want to take their product professionally. Enterprise innovators are those folks at giant corporations, giant enterprises, who are the Doc Browns of the world, the prototypers in the corporations, in the enterprises, looking for new ideas and new technologies. Startups are exactly what you'd expect. They're the new breed of IoT startups, and there's our traditional OEM business as well. We looked at these groups of developers and really saw that there's three clusters. The first are makers who turn to Windows IoT Core for learning devices. They don't necessarily know a lot about hardware, and they don't know a lot about software. But using Windows 10 IoT Core, they can learn both hardware and software together, and making it so any maker can build an IoT device. The middle grouping are developers. Developers are the ones who already know the Windows platform, and they prefer the Windows developer experience for devices. And the last are the startups and OEMs making up manufacturers. We want manufacturers to trust Windows IoT Core to go to market. And as you can see, each of these bubbles is growing smaller and smaller. The reason for that is because the first is really an engagement play. The second is the dev ecosystem play. And the third is a volume play. And here's the money point. We believe that devices are the new apps. Any developer can build an IoT device. If you know how to program, or you want to learn how to program, and you want to learn hardware, you are capable of building an IoT device. And that's what I'm going to show you today, because devices are the new apps. When we talk about our pillars, the first one we talk about is the One Windows platform. And I break it up into three pieces. The first is the universal Windows platform. At the end of the day, Windows 10 IoT Core is not some side project away from the rest of the Windows ecosystem. Windows 10 IoT Core is the core of the Windows ecosystem. It's the core of the Windows editions. And it's built squarely on the same universal Windows platform you're either familiar with, or by the time you're done with build, you'll be familiar with. It's the same developer experience, and we'll talk more about that. And for our One Windows platform, we've created something that I'll be announcing a little bit later called the Windows IoT Remote Client, just to whet your appetite right now. So moving forward, the Universal Windows Platform, because it's UWP, you can scale app investments across multiple device types. You can do your development on a Windows desktop PC and then just deploy to a Raspberry Pi or a Qualcomm Dragon board. Your UWP and your XAML will just translate between the two different devices. It's as simple as recompiling and redeploying your app. Common and consistent APIs. It's the universal Windows platform. You want to new up a media element? It's the same functionality. You want to do socket communication? It's the same. Reuse existing code and development skills. We'll talk about that one a little bit more. Let's talk about the developer experience. As we started, IoT devices, some have displays, some don't. You can create experiences with our developer experience for devices with and without displays. You got familiar tools and familiar processes, Visual Studio, all the services that you love, and you can bring your code to Windows. Digging in more into those familiar tools and familiar processes, you'll notice that we have a whole family of Windows devices. I want to stress that. It's a family. First, you have your phones, your tablets, and your small devices. You have your large Surface hubs. You have your 2-in-1s and your PCs. You have your Xbox One. You have your HoloLens. And at the center, you have dev boards, specifically the Middleboard Max, the Raspberry Pi, and the Qualcomm Dragon Board 410C. And for all of them, because it's the same universal Windows platform, because it's the same tools, you have your IDE and designers of Visual Studio and Blend. You have app updates through the store, the Windows Store, and you have cloud services that you can connect to like Azure. It's one Windows family, one tool set, one app. We have support for multiple languages, which we'll cover more, and it's a universal driver model. So if your application on the desktop already runs with a universal driver model and you use custom hardware, you can just bring it to IoT Core without any problem. one dev center with the ability to flexibly target multiple different device families, as we talked about. And existing code is welcome. We want your modern applications on the PC onto IoT devices. We want your modern applications from the phone onto IoT devices, as well as your mobile websites. Earlier in the week, there have been a couple sessions where we've shown web apps running on IoT Core, which is a pretty cool thing. You can take your JavaScript web apps, they just run on IoT Core because it's just the universal Windows platform. Microsoft provides the tools and services to bring your device to market faster. So let's get into some demos. When I started, I talked about the three classes of the developers, of the developer ecosystem. So what we're going to do is we're going to start all the way on the left with the learners. And what I'm going to do is I'm going to switch to number 7. Let me go to number 1. All right. What I have here is a Raspberry Pi 3 with a Sense Hat on top of it, or a Raspberry Pi 2 with a Sense Hat on top of it. The Sense Hat has an LED display, as you can see right here. Okay? What I'm going to do is I'm going to switch over to this computer. And what we have is on that device, we have a Node.js server running on the Universal Windows platform. And what we've got here is I'm connected to the server. The name of the device is blockly.local at port 8000. And what I have is, who here has seen Blockly or some other type of visual programming language like Blockly? All right. So what Blockly allows you to do, for those learners in the audience, or for those of you that might have kids or nephews or nieces, what Blockly allows you to do is get started with programming on the Windows 10 IoT Core platform. And so what I'm going to do is very simply, I'm going to pick a block. We'll call it show number 2. I'll grab some logic. Grab a loop, actually. We'll do a repeat 10 times. I'll snap the show number 2 in here. And I'll grab math, and I'll pick a random number and replace it in the 2. So, and then finally, I will add a pause right here. Pretty simple. A couple seconds, and I've got an entire piece of code. What this is going to do is it's going to repeat 10 times. It'll show a random number from 0 to 4. It'll pause for 100 seconds, and it'll repeat that 10 times. So now what I'm going to do is I'm going to switch to my overhead, just like in college. Yeah? Random didn't connect. Let's fix that. You're correct. That's now fixed. Thank you for pointing that out. I've got that now. I'll show that to you. Thank you very much for pointing that out. And so now what we're going to do is we're going to run it. And if it works, you can see it's a little bit bright, but there it goes, random numbers, 2, 0, 4, 0, et cetera. Pretty easy. And it's displaying those out to the Raspberry Pi and to the Sense Hat. So the question is, how did that actually work? So the nice thing is that if you're a learner, you can just get started with just putting these blocks together and learn computational programming. But because this is the power of Windows 10 and the fact that it's the universal Windows platform, it ends up that this is all just JavaScript code. And so as you can see here, we knew up a helper that was implemented for Blockly. We accessed the GPIO, general purpose input-output, which allows us to communicate with the Sense Hat, to communicate with the I/O on the board. We knew up the Sense Hat, and this is actually pretty cool. This Sense Hat functionality is just part of the Universal Windows platform because it's an open source library that was created by a community member. They created a WinRT component for the Sense Hat, for this device, put it out on GitHub, and we were able to integrate it into this project by one call from JavaScript. It's actually pretty cool, okay? And then we have the loop going from 0 to 10. We have the Sense Hat. We print out the value. We switch the color to blue, and then we do a pause in our basic object. Pretty simple. So let's make it a little bit more complex. And the great thing is, because it's JavaScript, the GPIO functionality on Windows 10 IoT Core, just part of the platform. You knew up GPIO, you call into it, it's all good. So what we're going to do now is we've got a pre-canned program. What this is going to do is it's going to show a string, welcome to build 2016. It'll loop forever. It'll clear the screen, pause for 300 milliseconds, show a pattern in the LEDs, pause again, and repeat. So I'm going to deploy it, pop it up here. There it goes. Welcome to build 2016. You guys can applaud if you want. It's fine. So welcome to build 2016. And then now, there's the blinking heart, because we love Windows 10 IoT Core. All right, so I'm going to trash that project, stop it running. So the thing is, I talked about the Sense Hat. There we go. There we go. Let me refresh this so you guys can see it. We talked about the Sense Hat, and the Sense Hat is great as an output device, but it's also got an accelerometer on it. So why don't we put that to good use? Now that we've taught using Blockly, we've been able to project a small little heart and been able to project some letters and some numbers and some random numbers. Let's see if we can actually get input from the environment. Because at the end of the day, what are we trying to do? We're trying to learn and teach that any developer can be a IoT developer. Any developer can do hardware, and it's simple. Because devices are the new apps. And so part of being an IoT device is getting input as well as output. So what we're going to do is we're going to, this program, as you can see, it's going to use the accelerometer on that Sense Hat. So we're going to run it. So now it's going to say, oh, whoops, I should project up. So what we see is a little ball. I'm going to pick it up. And as I tilt using the accelerometer, the ball will go to the different sides. Now, that's great if you're just getting started, you've never programmed before. So Blockly's pretty cool. But for some people, the journey doesn't start at Blockly. As you move down that continuum of the different developer personas, what you find is some people start with an Arduino project. So what I'm going to do is I'm going to remove this. I'm going to bring this down. Let me project that up. So what we have here is what a typical Arduino project looks like, okay? Except there's one big difference between a traditional Arduino project and this one. Who can guess what that is? Hands? Anybody? There's no Arduino in this project. It's a Raspberry Pi 2. The reason for that is because sometimes you want to develop using the Universal Windows platform, but you want to use wiring code from Arduino. And so what we have here is a breadboard, some resistors, a potentiometer, an LCD screen, all hooked up. And this can look daunting because if it's all wires, if you're only if you're a software developer and you've never done hardware, this can be pretty daunting. But a lot of people, their entry point into the IoT journey comes at using the Arduino IDE. And so we figured, you know what? Why don't we make the Arduino IDE work with Windows 10 IoT Core? So what I'm going to show you now is I'm going to open up a project. OK, good. So it's a very simple INO. OK, who here has done Arduino programming before? OK, good. So this is Arduino wiring. This is the Arduino IDE. They've done a fantastic job with it. We have a couple functions. The first thing we do is we get a liquid crystal display. It's just part of the Arduino wiring libraries. We get a pointer to it. We create this print line, which takes in a row and a text array. We set the cursor to the 0 in the row. We call print on the LCD. Our setup, so every Arduino program, every Arduino wiring program has a setup and a loop. And the idea is setup is where you do all your initialization, and loop is constantly called by the Arduino runtime to over and over loop a specific piece of functionality. So our setup is we new up the liquid crystal. And these GPIO ports, you'll notice that on an Arduino, they don't go up to 26 or 20. The reason they do is because we have GPIO ports on the Raspberry Pi 2 that go that high. So the only difference here is we've changed our wiring code rather than specify the GPIO ports of an Arduino to the GPIO ports of the Raspberry Pi 2. And the loop will just say hello build from Arduino IDE. So if the LCD says that, that means we're actually communicating. And what I'm going to do, you'll notice that the programmer is set for Windows 10 compared to the other Arduino-compatible devices. The processor is set to ARM instead of x86. And the board that we're talking to is Windows 10 IoT Core. So what I'm going to do now is I'm going to upload this sketch. I'm going to type in, the name of the device is arduino.local. And if you look down here, the build is started. We'll give it a minute. it started to compile and create the AppX, which is just your standard Windows 10 WinRT or AppX. So it's now removing the previous installation. Still uploading. Done uploading. And you can see here it says hello build from Arduino IDE. So now we've shown your journey starting at Blockly and moving into the Arduino IDE. Now, that's cool, but for some, for some people, for some developers, the journey doesn't start at the Arduino IDE. A lot of you are actually comfortable with Visual Studio. The problem is the languages might be a little bit much for you. So what we've done is we've set up the next step of that journey. So I'm in Visual Studio now. I'm going to open up my demos. We're going to go to this one called Arduino Wiring LCD. I'm going to open it up. And what you see here is a Windows 10 IoT Core Arduino wiring project. You'll notice that the INO is loaded right here. It's not a CPP file. There's no other GUI in here. This is a INO. And what we've, one thing I need to do before I do this demo. So what I'm showing here is the web interface to all of the Raspberry Pis that I've got set up. I need to stop the INO from running, which I will do right here. Oops. I'll trash it, actually. All right. Going back to Visual Studio. So what you see is it's the exact same code you saw before in the Arduino IDE. Here's your creation of the liquid, or the pointer for the liquid crystal display and the liquid crystal header. Here's the print line that we saw before. Here's the setup. Here's the loop. But here I've changed it to say hello build from VS. So now what we're going to do is I'm going to switch over. You guys have all seen Visual Studio deploy. So in the interest of time, I'm going to start up. And what should happen, if this works, there it is. So the next step of the journey is, for some people, it's great that we have a wiring functionality, Arduino wiring functionality, built into the WinRT. But the nice thing is, because it's now part of the platform, you can start creating abstractions on top of it. So what I'm going to show now is I'm going to go to this next project. What this next project is, it's a solution that has two parts to it. One is the LCD controller, which you've seen before, but you'll notice that we don't do anything in the loop function anymore. Okay? What we've done is we've created a WinRT, a WinMD wrapper around it called the LCD controller. It's a very, very simple wrapper. It's got a constructor and it's got a print line method. Okay? The implementation is also very simple. The constructor, guess what? It just calls setup. And the print line basically converts the text string into a proper text string for WinRT, and then it calls the print line function. Pretty easy, okay? I jump to the main page.xaml, and in that, here you can see where the main page is loaded. We load up the LCD controller, which we now have an abstraction to. We create two callbacks on if there's a click in the UI. And down here, if there's a click in the UI, it'll print the line of what was clicked. So to make that real, what I'm going to do is I'm going to switch over. Now, this device has an HDMI connection. I'm going to project I'm going to run the program. So it's O2, and it's this one. So we'll stop that from running. All right. Start this one up. Now, you'll notice here it says XAML initialized. That's the first point. Okay, so that means that the XAML main page is talking to the Arduino INO through the WinMD abstraction. But the next thing we're going to do is that is 8. So as you can see, we have a little text box here. I'm going to turn my little keyboard on. All right, so I'm going to type in here, hello, build live. All right, and then I'm going to print that. And if it worked, hello, build live. So the next step of the journey is now that we've built a WinMD abstraction and we can put it into XAML, well, now what we can do is we can create an app service with that. So we'll close down this project. We'll open up the next one. And here what you have, you see, again, the project, the solution as the project, which has the LCD controller, the CPP, and the INO file. But what it also has is a startup task. And in here, you can see where here we are in, so we have an app service connection, we have a background task, and we have the run method. And in the run method, we simply new up the Arduino LCD controller, and we print line when it news up the service init. So what I'm going to do is I'm going to switch back to VGA. And so what should happen is now it's switched over. You can see it says service init. Okay, so there you go, first part. And then the second, so that's good. That means that the service has started running, and it's a background task that's running on this IoT Core device. The key here is there are two application models available within Windows 10 IoT Core. One is your traditional foreground application, which takes up your entire display and your entire, which takes up the, which becomes the UI for your experience on the device. But the other one is a background application service, which we just showed here. So what I'm going to do now is go back to Visual Studio, close down this project, and since we have a service running with that wiring code that we originally brought up through the Arduino IDE, I'm going to go create a XAML client that's just by itself. Notice that in this project, there is no wiring code anymore, because we now have a service that's abstracted that off. And what I'll show you is here is the main page loaded function, method, excuse me. And what we do here is we create a new app service connection. We give it the name of the service that's running. We give it the name of the package family, which is a very easy to read name, as you can tell. That was a joke, you guys can laugh. And then the next thing is when there's when the button is clicked, and it's a very similar UI to what you saw before, it'll send a message async back to the service. So putting that all into action, we'll come over here, we'll deploy that app. All right, cool. We'll switch over to the VGA. Oh, nope, wrong. We'll switch over here. So we got the same UI as we saw before. Now what I'm going to do is show there's no smoke and mirrors on this one. We'll say second line. And then I'll move over here, print, switch over to VGA. Second line, there it is, through an app service. So with that, what I just showed you is that with Windows 10 IoT Core, we've invested in the development experience, so it grows up, the development experience grows up with you. I first showed you that if you're starting out at the exploring stage of the continuum of the developer lifecycle, we've got Blockly for you. If you already know how to do simple, even complex Arduino functionality, and you're comfortable in the Arduino IDE, you can now deploy to Windows 10 IoT Core. And if you're comfortable already as a Windows developer using Visual Studio, but you want to get started with hardware, we've created an entry point for you to use all that open source code available for the Arduino on your IoT Core device through Visual Studio. That's the power of Windows 10 IoT Core. But let's say you're a skilled developer, more on the right side of that continuum of the developer spectrum. And you're really comfortable in Visual Studio. You want to write your own abstractions. You know C#. You know C++. Like, you've been a developer for years. But you're afraid of hardware. Well, do we have the right solution for you? What I'm going to do is I'm going to move this out of the display. Let me switch over to the VGA. All right, now I got to do this part carefully because I'm notorious for pulling out cables during the demo. So what I've got here is, let me move this here. This giant spider of functionality is a new kit for the Raspberry Pi 2 and the Raspberry Pi 3 from one of our partners, Seed Studios. And what you can see here is there's a Raspberry Pi 2 under here. There's a breakout board, and the key about this breakout board is you'll notice that there's no soldering and there's no breadboard. There's just these connectors, which are all consistent, that give you access to the different types of buses available from a Windows 10 IoT Core device. That includes GPIO, I2C, analog input and analog output, as well as SPI. And what's running off of these are little boards. This one's a LED bar. This one is a temperature sensor. This one is a sound sensor. We've got a light sensor as well. We have a distance sensor. And you'll also notice this little screen. What I've got, so and then we've also got the LCD screen over here that says Hello Build. So what I'm going to do is I'm going to go back to Visual Studio. I'm going to close down this project. And I'm going to go here. Now, the great thing is, from a hardware perspective, the folks at Seed Studios have created a board that you just slap on top of the Raspberry Pi, you hook super easy connections, and you can access a very large plethora of sensors and actuators in the open source a democratized hardware ecosystem. And what I mean by that is there's a lot of these types of devices that have already been created with the standard connection for the Grove Pi kit. What we've got here is a very simple demo app, which I'm going to walk you through. You can see it's just one solution and one project, and it's really just got a main page.xaml.cs. And so it's a C# project. And so here is the first place, which is our public main page. We initialize the component. We new up a timer, and we start the timer at a 100 millisecond interval. We then have a series of callbacks. The callback that we're going to focus on is this one, on test LCD check. Okay? We set a Boolean to that we've seen that we're testing the LCD. We have a singleton pattern here where if the LCD display doesn't exist, we new one up. And the nice thing is, not only has Seed created the Grove Pi kit so that the hardware is easy to use, but they've created an open source library that's dirt simple to use. You'll see it here. It's only a few lines of code, and you've got an LCD working. And so we new up the LCD. And there's just a note that it's going to be using the I2C bus, which is where it's connected. And then the next thing down here is we have an on-tick method. So remember we set up that timer. The timer is going to keep ticking at every 100 milliseconds. And we basically, there was a bunch of these callbacks that were set up for each of the different devices that's connected here. The one we're going to go to is down here a little bit. I have a marker for it. There it is. So the on-tick, it's right here. So the LCD, and we'll new up we'll create a text string. We'll generate a random red, green, blue value. We'll set the text. We'll set the background light, and we'll set the text of the LCD item on the display that you saw as well. So putting that all together, what that actually looks like is this. Oh, it started already. So what I'm going to do is okay, good, excellent. So here's the UI running. This is the app that we just wrote and deployed to this device. You can see there's a whole bunch of checkboxes for each of the different sensors and actuators. I'm going to go to the test LCD, and you'll notice that this LCD blinks, and it says Hello Build with the random color. Only a few lines of code, no soldering, and a breadboard-less connection. So today we're announcing the Seed Windows 10 IoT Core Grove Pi kit. It's an exclusive kit for Windows 10 IoT Core and the Raspberry Pi 3. It's easy to use, as you saw. It's solderless and breadboardless, and it's coming summer of 2016. So if you're interested in getting started with hardware, You know your software. You know how to write universal Windows applications. You know how to write Windows applications. But you're so scared of plugging in hardware and electrocuting yourself. This is the kit for you. And it's an exclusive because it's got this display in it as well. So now we've taken you through, yes, another demo, people. So now we've taken you through the learning journey, and we've started to get an onboard point where professional developers are coming to IoT devices and to hardware, because devices are the new apps. Because this is the universal Windows platform, we have language diversity. So say you wanted to build a weather station. Say you've already onboard, say you understand hardware, enough hardware to be dangerous, you're a professional developer, and you've got a product in mind, and you want to build a weather station. Well, the good news is, with that weather station, if you want to get the humidity and the temperature, you can do it in any universal Windows platform language. That includes Arduino wiring, which we've shown. Here, what you see is the loop function, where we read the humidity and read the temperature at the top. Read humidity is a function where we begin an I2C transaction, we request data from the I2C transaction, and then we pop out the actual value, and down at the bottom, that's where we get the humidity. Okay? Just looks like C code. It's Arduino wiring. It's a dialect of C. As you can see, it's a project that has an INO, just as we showed before. So you could implement your weather station in Arduino wiring. You could also do it in Node. So here you create a so at the very top, you can see that we are accessing the I2C device. That's the key here. Because I2C functionality is built into the Windows.Devices namespace within the Windows Universal Platform, you can just new up, find all async I2C devices, and then start calling into them. So in the middle, we have the creation of the server. We've got the humidity at the top and the temperature at the bottom. And basically, it's an I2C transaction through Node. Okay? And you can see the math being done to read the humidity and read the temperature. The key here is that how you're implementing the weather station also dictates how it's going to run and how it's going to communicate with the environment. The reason we support all these different languages is twofold. Number one, it's just the universal Windows platform. But two, it enables you to have the creativity you need and meet the constraints and the demands of what your project or what your product needs in order to be successful. So we're not dictating it's only possible through C# to access GPIO or I2C, as an example. You can also do it through Python. It happens that Python is the quickest way to do the weather station. So again, at the very top, we access the I2C bus. Then we basically repeat, and we loop. We get the temp ratio, we print the temperature, we get the humidity, do the calculation, and print it out. Again, exact same logic, completely different code base. And you can see that it's just a Python project on the right. Oh, and to show the Node one as well, it's just a Node project on the right as well. I went back one slide. Now, for some of you who still like to use Visual Basic, it's part of the Universal Windows platform. Here's the code in Visual Basic. I'm not going to go through this because it's Visual Basic, but you get the idea. You also get the weather station in C++. So here we're doing it as a startup task, so it's a background task. We have a run method. The run is going to get the I2C bus, make calls against it, and then at the bottom we have a timer which is going to elapse and handle the timer event. And basically we pull the humidity and pull the temperature. C++ code. And guess what ends? C#. There's the exact same weather station in C#. In all 6 of the Universal Windows Platform languages, you can access buses and the runtime from all the UWP languages. And you can develop in the language and framework of your choice. Arduino wiring, Node, Python, Visual Basic, C++, C#. And for the one of you that's going to ask, yes, F# works as well. So part of the IoT sphere or the IoT mantra is really embracing open source software. And we're doing that as part of our IoT group. There are 3 places that I want to key in on. Number 1, documentation, tools, and samples is all open source. You go to windowsondevices.com, all of that is open source for you. All of our all-join bridges and communication software has all been open sourced as well. And today I'm proud to announce, some of you may have seen it, but we're announcing it today, that the Raspberry Pi board support package and the drivers for that board support package, some of them have already been published and some of them are coming soon, okay? What this allows you to do is actually see how we implemented GPIO, I2C, SPI, the serial mini, UART driver, pulse width modulation in source code so you can go and make modifications yourself. Because where we're at in the journey is we've now gone from learners to professional developers, and now you've got a product, you've got a weather station you want to build. It's time to go to through the journey of commercialization. We are continuously open sourcing more code to help you be more productive in building the products that you want to create on the Windows 10 IoT Core platform. So now let's talk about the Windows IoT remote client. 3 key messages here. We're putting a display on every displayless device. You can program remote sensors locally, and you can have inter-device communication with no extra developer work. What does that mean? Well, before we talk about the Windows IoT client experience, let's talk about Continuum, because it sets the context for what we've developed here. As you know, Continuum for the PC transforms a traditional PC into a tablet and vice versa. Continuum for phone transforms a traditional phone experience into a full PC, and the functionality is available out of the box. With Windows IoT Remote Client, you can transform a traditional IoT experience, one that may not have a display connected or a keyboard or a mouse, into you can take that displayless device and put a display on it. And today we're announcing that the Windows IoT Remote Client is available in the store for you to download and use. So what does that mean? Couple things. The out-of-box experience is super simple. On your Windows 10 IoT Core device, you simply enable the remote client through the web interface, which I showed you earlier. The second thing you do is you install the Windows IoT Remote Client on any Windows device. Let me emphasize that. Phones, tablets, PCs, all of them, Windows 10 devices, it doesn't matter. It's a universal Windows application. You download it from the store, you install it on your Windows 10 device, and then you create a bridge between the Windows 10 IoT Core device and that app. So to give and doing that, A, you put a display on every displayless device. But B, the code that's running, and this is a key point, the code that's running, you didn't have to build any communication code. All of your business logic and all of your UI that's going to be remoted to that application is all written on your Windows 10 IoT Core device. No more back and forth between a client and a server of code that you have to write and maintain. No more do you have to deploy it to 2 different locations. And in addition to that, your business logic is what drives your UI. And the UI can be hidden when you don't have a display connected, because sometimes it's hard to get that display connected to a robot or an automation factory device. And other times, it's just inconvenient. And so to drive that point home, what I'm going to show here, we created a video that pretty much sums this up. And you can see this, this hardware setup down in the hub. It was available yesterday and it'll be available today as well.
Now let's see how Windows can put a head to any headless device. Here we have a wheel connected to a Raspberry Pi 3 running Windows 10 IoT Core. The wheel represents a common situation in robotics, when you need to know exactly how fast a robot's going or how far it's traveling. Here I have a display connected to the Raspberry Pi 3. You can see the speed of the wheel, the speed I've chosen, and the power output to the motor. But real-world systems deal with real-world problems, like friction. Let me offer some frictional force. We see exactly what we expect. The speed of the wheel slows down, but the power output to the motor stays the same. Let's do another take where I apply the bar again, this time with the closed-loop control setting on. You'll see that the Raspberry Pi increases power output to the motor to maintain a relatively stable RPM. With Windows 10 IoT Core and the Raspberry Pi 3, you can now build these types of high-speed, closed-loop feedback control systems. But let's take it a step further. Sometimes you don't want a display connected to your device. Here we have a tablet running Windows 10 that's running an app that was downloaded from the Microsoft Store. Windows 10 IoT Core allows the Raspberry Pi 3 to remote its UI experience to this tablet. The Raspberry Pi receives touch data from the tablet as well as accelerometer data. You can see here the wheel is being controlled by the accelerometer inside this tablet. Windows 10 IoT Core on the Raspberry Pi 3 is designed to interact with the physical world and empower your applications to do the same. You can use the remote sensor functionality from your Windows 10 capable device and program it onto your Raspberry Pi 3. By enabling remote UI, touch input, and sensor data readings, Windows 10 puts a head on any headless device. That's the power of Windows 10 IoT Core and the Raspberry Pi 3.
Applause is fine. So with that, a couple key points to make. With that launch demo, that was the demo that we used at the Raspberry Pi 3 launch on February 29th. Number one, that demo is showing closed-loop control. It's using proportional integral derivative control as an example, and it's using our high-performance GPIO interrupts via what we created called the lightning driver to be able to satisfy the rate at which that wheel spins. So closed-loop control is being demonstrated there for the first time on a Windows 10 IoT Core device, or when we did it at the launch for Raspberry Pi 3. In addition, it shows the Windows IoT remote client. There are two key points here. I talked earlier about remoting the display and the touch UX, but we're also remoting the accelerometer, as you saw in that video, and other sensors from the Windows 10 device to the IoT Core device. But the great thing is, to access that sensor, based on the help that we got from the sensors team, Rinku's sitting in the middle of the room, based on the help that we got, we were able to make it so on the Windows 10 IoT Core project, where we are actually controlling the wheel, we knew up a sensor, and it just remotes it back to the client experience. No extra code had to be written on the client experience to access that sensor. And it's an open source project. It's available on Hackster.io, and it's also available on GitHub. So now we've moved down the chain to somebody who's trying to do automation or a real-world project. We're showing the ability to do closed-loop control. Now, so we've talked about the One Windows platform on Windows 10 IoT Core. And let's say now you're comfortable with software, with hardware, you've got a project, it can do something that's innovative, and now you want to bring that thing to market. Well, that's what I'm here to help you also with. We're going to talk quickly about getting to market, keeping up to date, and adjusting customer feedback. So number one, when you want to get to market, you really want to take your one idea and make many of them. So we're going to talk about how to do that, the IoT Insider Labs, and the OEM lifecycle. Let's talk about from one to many. So this is a traditional journey that happens in embedded or IoT, in the embedded or IoT world. You start with a prototype, you have one board, you have less than 20. You then move to a small run of less than 1,000. You then do a boutique run of less than 5,000. And then you want to go to production, which is typically over 5,000. Okay? Typically, with a different platform, you switch tooling and the silicon as well as the operating system as you move through these different phases, and you constantly have to retool. The key here is that as the customization level increases, with Windows 10 IoT Core, one Windows platform remains consistent. You can go from one all the way to many in production. And the key here is we're working with partners like Element 14 for the Raspberry Pi to allow you to do customization of the Raspberry Pi to suit your needs for a small run boutique and a production run. In addition, with Qualcomm, you can buy the chips directly and create a small run boutique and a production run. And again, with Intel, you can do the same thing to create a small run boutique and production. And so to help with that, the key is that it's the same developer platform, it's the same developer tools, it's the same services, going all the way from one all the way to many. So today I'm announcing something new to help you go through that journey. Microsoft has created the IoT Insider program and set up IoT Insider Labs. These Insider Labs are in Redmond and Shenzhen currently, and we have engineers on staff to help you with PCB prototyping, small-scale manufacturing through the extensive partner network that we have, device and app development assistance, so if you need help in developing your software or hardware, and also integration into cloud data collection, analytics, and ML via Azure. Those labs are part of our IoT Insider program, which is designed to help accelerate IoT projects on Windows or Azure, offer technical and business assistance, and help with small and large-scale manufacture. And we're taking nominations for projects now. If you have a single prototype, or you want to get to a prototype, and you want to bring that out to production, we're here to help. Send your projects to iotinsider@microsoft.com. Now announcing this new program. So now you've learned the software, you've built up the hardware, you've also gotten comfortable at building one prototype, you've gotten that out to your friends and family and your coworkers, you've partnered with Microsoft to help you on the journey of getting to production, you're using one set of tooling all the way through this journey. Now you need to keep those devices updated and reliable in the field. So what I'm going to do is I'm going to play one more video.
With the latest Insider release of Windows 10 IoT Core, Windows Store applications can now be added to an IoT Core image at image creation time and be serviced via an app update through the store itself.
You don't see video? Oh, it's going to remain stationary. So what we're going to show here real quick is that Windows 10 IoT Core Anniversary Edition now supports the ability to put a Windows Store application onto your IoT Core device and field service it via the store backend. And so this video walks through that entire process.
With the latest Insider release of Windows 10 IoT Core, Windows Store applications can now be added to an IoT Core image at image creation time and be serviced via an app update through the store itself. Note that your app will not be publicly visible in the store, nor will you be able to browse the store directly from an IoT Core device. Let's do a high-level walkthrough of including a Windows Store application directly into a Windows 10 IoT Core image, as well as issuing an app update to already deployed applications. Don't worry if you can't remember the steps, we'll make the slides and a more detailed walkthrough available online. Built into Visual Studio, the Windows Store application development and deployment process is the same across all Windows 10 devices, including Windows 10 IoT Core. To create a custom Windows 10 IoT Core image with your application, you will need several additional tools and samples. First, you'll need the Windows 10 Assessment and Deployment Kit, which includes the tools necessary to create a custom image. You will also need the Windows 10 IoT Core OS Kit, which is available on MSDN. More detailed documentation and samples are available on GitHub and on MSDN, including step-by-step videos. Once your application is complete, you will need to get the AppX signed through the Windows Store certification process. Then you'll use the ADK to create a new Windows 10 IoT Core device image with your application built in. Once you have the new image, you can deploy the image directly to your device. If an issue occurs with your application, or you just want to update it, you can remotely deploy and debug your application with Visual Studio and repeat the typical deployment process until your application is finalized once again. If you don't have the device locally, you can remotely investigate using the new Windows 10 IoT Core remote client from another Windows 10 device, such as a PC or a phone. The Windows 10 IoT client is available in the App Store. Now you can submit the new version of the application to the Windows Store, which automatically will push the new update out to devices in the field that contain your existing application. Developing and deploying a store application to the Windows 10 IoT Core device is the same process as other Windows 10 desktop and phone devices. The same universal APIs and tools and the same store process. That's the power of Windows 10 and universal applications.
So OneStore apps are now available for, you can use OneStore apps to service applications installed at runtime when you create your image. That's the power of Windows 10. So to recap that, the OEM lifecycle of building custom images, adding Windows Store apps to the image, diagnosing field issues using our new remote client and Visual Studio, servicing those pre-imaged apps using the Windows Store is all available now today with the latest Insider update. So in summary, there are 5 things I want you to take away. Number 1, I want you to feel that any developer can build an IoT device. Number 2, devices really are the new apps. Number 3, the developer experience grows with you all the way from a learner to an OEM. You can put a display on every displayless device with the Windows 10 IoT client, remote client, and it's one Windows platform. Microsoft is here to help you get from maker to market. But that's not all. You may remember this robot from the HoloLens. Who here was at Build last year? Okay. So what we have up here is the HoloLens robot. This is the base that we use for the HoloLens demo. It's up here. You guys can come and take a look at it at the end. But what we've done is we've put 2 cameras on the front of the robot. And what I'm going to show you, let me get back to Visual Studio, is we thought, wow, that's a great HoloLens demo, and it was fantastic last year. But we wanted to see what we could do to create a similar type of experience with Windows 10 IoT Core. And so Lou, who's sitting up front here, it's not HoloLens and IoT Core, let me be clear about that. What we've done is we thought, since it's just the Windows Universal Platform, what we will do, I'm opening up the project. I'm going to go to the main page.xaml. So this is all the code to get the HoloLens robot as well as the drive functionality, which was already, this has all been open source. It's available on GitHub previously after Build last year. What we did is we created 2 new media capture elements, one for left and one for right. We then here connect to camera with 1 and 0. The connect to camera function, which is here, it's only about 15 lines of code. We create a new media capture because this is just the Universal Windows platform. We find all asynchronous video capture devices. We make sure that our index is in bounds. We create a camera device. We initialize it asynchronously. We get the camera properties off of it. This is all just standard Universal Windows code. We iterate through each of the properties. And then through each of those, we look for the 320 by 240 resolution. And then we simply create a preview async. So, Lou, if you want to come up here. I'm going to switch to, what was the ID? I don't know. OK. I think it's 8. Oh, no, it's Miracast. Here we go. So I will now deploy the app. So this is an example of that app. You see it newed up the 2 media elements, and it's getting them from the cameras here, 15 lines of code that we added. But we thought, hey, if we can create 2 media elements, what else could we do with it with the things that we've just shown you? We've shown you the Universal Windows platform. It was just adding 15 lines of code. Couldn't we use our Windows IoT remote experience to do something cool? Lou?
Switch it over to the...
Yes, to... Oh, yes. So what Lou has here is a Windows phone. The phone is a Windows 10 phone. It's remoting the experience via the Windows IoT remote client. Lou's putting it into a set of off-the-shelf VR, stereoscopic glasses. He's putting it in, and he's going to put it on top of his head. We've just created an inexpensive stereoscopic 3D experience. If you look in those glasses, you're looking at a 3D. You're looking at a 3D, a stereoscopic 3D image. And if that's not enough, Lou's going to be able to drive the robot around with the controller and get a stereoscopic 3D view of what the robot sees. That's the power of Windows 10. No extra code was written for Lou to be able to remote that experience beyond those 15 lines of newing up the media element. So with that, we've gone across the entire developer journey. We've shown how somebody starting all the way up Lockly to an OEM who wants to create multiple devices, the Microsoft stack is there to help you from day one to get all the way out from maker to market. Well, the stereoscopic 3D demo shows the robot base from Build 2015 with the source code available on GitHub. The Windows IoT remote client using the display and the accelerometer to drive the robot. The wireless, when Lou tilts his head up and down, he can actually see what the robot sees. A wireless Xbox controller, and off-the-shelf low-cost stereoscopic 3D with the headset, the dual cameras, and the Windows 10 phone. As a call to action or learning more, we've got multiple sessions. We have the IoT Vision and Roadmap session I mentioned, the Windows and the Smart Home session, IoT Code Labs, IoT Coding Challenges, the web apps across Windows devices, and customizing your device experience with assigned access pre-record. There's a lot about IoT happening at Build. The final call to action is go check out windowsondevices.com. It's refreshingly complete. It has all the data you need to get started, all the way from maker to market. And revisit Build on Channel 9. With that, completed evaluation form. We had a lot of demos up here. We want to make this an exciting talk for you. We went through videos and we went through hardware and software and tried to hit upon every different type of developer in this audience. And with that, I want to thank you, the audience, for giving me the time to talk to you. And I also want to ask Devin, Jesse, Partha, Lou, and Ale, if he's in the room, to stand up, because you guys were fantastic in helping with all these demos and putting them together. Thank you all.